Hello and welcome to this session. Here we are going to examine the Liskov substitution principle in depth. We will take two examples and analyze and find out the design flaws in each one of them. Then we will apply the Liskov substitution principle and improve the design. Let's get started with the first example. We have a generic car class. We have a racing car, the ones from the Formula 1 racing. Racing car extends car. The arrow shows inheritance. Let's see what the code looks like now. The car class has one method, getCabinWidth, that returns the cabin width of the car. The racing car class overrides the getCabinWidth function and leaves it unimplemented. Why? That's because racing cars have a set of specifications, some of which might not match that of a generic car. So, this is what the interior of a generic car and a racing car look like. In a generic car, we call the width as cabin width. But in a racing car, there is no cabin. The interior space is called a cockpit. So racing cars do not have a cabin width, but they have a cockpit width. So the racing car implements a getCockpitWidth method accordingly. Now let's create some objects of cars and racing cars and play around with it. In order to do this, we will look at a util class called carUtils. So carUtils instantiates three objects with reference type car. Note that even though the reference for all three objects is car, two of them are generic car instances. The third one is a racing car instance. We insert all three car reference objects into an array list and name it myCars. Next, we iterate through the car list and we print out the cabin width of each car. Go through this iteration in your mind. The first two objects are car objects, so the getCabinWidth method works fine. But in the third iteration, the object is a racing car object, and racing car overrides the getCabinWidth method and leaves it unimplemented. So in the third iteration, this code will not work correctly because of an unimplemented method. So this is the design hole that has been exposed. So how do you fix this? We have to strike at the root, which is the inheritance itself. So we have to break the inheritance. Racing car should no longer extend car. Instead, we'll come up with a common parent for both. So we create a new class called vehicle, which is a very generic class which can represent any modes of transportation, including a truck, a boat, or an airplane. Then we make both car and racing car extend this vehicle class. We need to restructure the code also accordingly. Let's see how that can be done. First is the vehicle class, which has one method called getInteriorWidth. Note that it is neither cabin width nor cockpit width, but a much more generic abstraction called interior width. Next, we have the car class that extends vehicle. The car class overrides the getInteriorWidth, which in turn calls its getCabinWidth method internally. Next, we have the racing car class that also extends vehicle. The racing car class also overrides the same getInteriorWidth, which in turn calls its getCockpitWidth method internally. So that's the code restructuring that is needed to follow the new hierarchy. Finally, let's look at the same CarUtils class again. We have renamed it to VehicleUtils, by the way. Again, we have the first two car objects and the third racing car object. Note that all three are of reference type vehicle. Iterate through this loop in your mind. First two iterations, the getInteriorWidth method gets called on the car objects. The car objects in turn call their getCabinWidth method. In the third and last iteration, the getInteriorWidth method gets called on the racing car objects, which in turn call their getCockpitWidth method. So all calls work correctly. And the whole thing is dynamic. Because of the way we designed the hierarchy, we can simply iterate through any number of objects of reference type vehicle and get the interior width without ever bothering to know if they are car objects or racing car objects. What we saw now was our first example for applying the Liskov substitution principle. So the solution that we applied to this pattern of problems is called breaking the hierarchy. There is one more pattern where we apply the Liskov substitution principle in a different way. We will see that in the next session.